Hello, everyone. My name is Shalini Mishra, and I'm here with my fellow teammates, Shradha Shrestha and Sapana Shrestha. We have a really interesting project to present today, which we implemented as a part of our AI course. The name of our project is Tic-Tac-Toe, and the realm of AI that it uses is reinforcement learning. The objectives of our project is to create an intelligent system that can optimally play tic-tac-toe, and reinforcement learning could be used to meet this objective. And it has two phases that is training phase and test phase, where two different AI agents can play against each other during the training phase, and the trained AI model will play against a human being during the test phase. So as I mentioned earlier, reinforcement learning is the chosen approach for our project, and it contains three elements, and they are state, action, and reward. And in this project, we'll be training the model, and then we will be allowing it to play against a human being. So let me explain what reinforcement learning is and how it actually works. So there are a certain number of states of any problem to be solved. One of these states is the goal state, which is to be ideally achieved. Then there is another factor called an action, which is taken over a state. The system is supposed to take an action on the current state, which may not lead to the goal state. While training, our system takes action and receives a reward based on whether that action leads to the goal state or not. And based on these rewards, the system then learns what actions should actually be taken on what state. So these are the steps involved in setting up tic-tac-toe. And the steps are two agents playing against each other, and then the rewards that are provided based on the actions. A policy is then set up based on this reward, and the model becomes ready to play against the human. After the model becomes ready, it plays against the human being. So the technologies that we have used for this project is Python, whereas the IDE used is VS Code, and the version control is GitHub. So as the deliverables of our project, we are going to be submitting a link to a YouTube video that will contain the demonstration of our code, and a submission of a GitHub link having the repository of the entire code along with the documentation. So the project can be evaluated based on these criteria, and most of which is the accurate functioning of the AI agent without any failures during the game. The final goal and actions of the agent should be based on defeating the opponent agent while training, and the human or the user while actual implementation. The agent should be trained in such a way that while playing with a human player, it should seem as if two human brains are playing, and also the correct implementation of reinforcement learning and the algorithms based on it. So this is precisely how we have designed the tic-tac-toe game, and let us now analyze how our code works, which will be explained by Shradha.
Hello everybody, so let's get started with the code explanation. So here, this is the main function. Here we have two classes, player and state. First of all, we create two agents, two objects of the player class as agents, so that we can train them to make them ready to play with human. And then after training them for a specified number of rounds, we will make one of the agent play against the human. So here we also have the state class. So talking about the state class, the state acts as both board and judger. It has functions recording both state of both the players and update state when either the players take an action. Meanwhile, it is also able to judge the end of the game and give rewards to the player accordingly. So let's go to the state class. Here in the state class, inside the init function, we initialize a vacant board and two players, P1 and P2. We initialize P1 to play first. Each player has a play symbol. When a player takes an action, its player symbol will be filled in the board and the board state will be updated. In the get hash function, it hashes the current board state so that it can be stored in the state value dictionary. The update state function what it does is, when a player takes an action, its corresponding symbol will be filled in the board. Also, it updates the current vacant positions on the board and feed it back to the next player in turn. So the winner function continuously checks if the game has ended after each action of the player, and if the game has ended, it decides the winner of the game and gives reward to both the players. So the give reward function, it takes the return from the winner function and then feeds rewards to the player accordingly. So now let's go to the player class. The player class represents our agent. Each player is able to choose action based on current estimation of the states, record all the states of the game, update state value estimation after each game, and save and load the policy. In this class, we initialize a dictionary storing state value pair and update estimates at the end of each game. Here in the init function, we keep track of all the positions a player has been taken during each game in a list, which is states, and update the corresponding states in a dictionary, state value dictionary. In terms of choosing action, we use epsilon greedy method to balance between exploration and exploitation. Here we set the EXP rate to 0.3, which means that epsilon equals to 0.3. So 70% of the time, our agent will take greedy action, which is choosing action based on current estimation of the state value. And 30% of the time, our agent will take random action. So here in the decide action function, if np.random is less than or equal to 0.3, it takes a random action. And if it's greater than 0.3, it takes greedy action. So now let's move towards the feed reward function. Here, to update the value estimation of states, we will apply value iteration, which is updated based on the formula of reinforcement learning, which is this formula over here. We have applied this formula here. The formula simply tells us that the updated value of the state t equals the current value of state t plus the difference between the next value of the state and the value of the current state multiplied by a learning rate alpha. So we update the current value slowly based on this formula. Now let's go to the play function of the state class. So now that our agent is able to learn by updating the value estimation and also our board is all set up, we now train the two players by making them play against each other. This is covered inside the play function. So inside this function, each player does a series of things, look for available positions, choose action, update board state, and add action to the player state, and also judge if it has reached the end of the game and give reward accordingly. So now, after the training is ended, we save the policy into files. We later use these policies to play against human player. Let's go to the human player class. So now our agent is all set up. In the last step, we need a human class to manage to play against the agent. So this is the human player class. In this, we only have one usable function, that is decide action, which requires us to input the board position we hope to take. So we need to input rows and columns each start from 0. So if we need to select the first box, we need to put the input as 0, 0. And we also need to modify a bit on the play function inside the state to play against a human. So we create another play function called play2 function. So this is the play2 function. It is pretty much the same. The only difference is that it lets the player 1, which is our agent, to play first, and at each step, the board is printed. So to look at how the code actually works, my friend Sapana will take over.
Hi, I'm Sapna. Now let's have a look at how the code works. Let's run the code. So first of all, the two computer agents will train for 5,000 rounds and learn and build the policy. The policy will be saved and used by one of the agents to play against a human after the training. Let's wait for a while for the training to get completed. Now the computer agent is ready to play with a human. Let's play. First of all, we select the first box. This box, so with values 0, 0. Here we can see the agent has taken a smart move such that its chances of winning is high, with only one box left to be ticked. Let's make it easy for the agent and tick another box rather than the box that makes the agent win. Here, we can see that the agent has played very well and used his policy to successfully win the game. Now, let's again play the game, and this time we'll play in full defense. Let's read on the code. The agent gets into the training phase. Let's wait a while. Okay, now let's input our values. Let's select first box. Let's select the first box, value from the row from the first box. Okay, again, the computer won. Now let's play third time. Let's choose the first box. So we have a tie now. We can see that the agent have trained very well and is very much capable to play against any human and give a very good computation. So this pretty much sums up our project. Thank you so much.